Hello, this is Mr. Huber. In this lesson, we're going to look at algebraic expressions. This is an area where we want to pay particular attention to vocabulary, terminology, understanding what those words mean when we see them in terms of the math that we could do with them. Often we might know the calculations, the operations, the math, but if we don't know when to use them and how to use them in the situations, they don't do us any good. So we want to know when we see some verbal phrases, how can we turn those into mathematical expressions that we can then work with. So here's a few examples, some words you're probably familiar with, some maybe not. And there's a bigger list than even these, but this will be enough to get us started. And you're going to want to pay, again, particular attention to what those phrases mean and how we can use them mathematically. Another one to be on the lookout for is the quantity. That indicates that we're grouping things together as an entire quantity. We see an example here, 4 less than the quantity 6 times the number n. So another particular thing to pay attention to here is 4 less than. 4 less than indicates we're taking the 4 away from something. Okay, if you have $4 less than I have, that means you'd find out what I have and take 4 away, not do 4 minus what I have. So we want to take 4 away from something. What do we want to take it away from? The quantity 6 times the number n. We're taking away from that whole quantity. When we multiply that, then we're going to subtract the 4. So the quantity 6 times the number n, 6n, we can just write together. That indicates we're multiplying the 6 and the n. There's a couple other examples. 3 times the sum of a number m and 7. So in this instance, we're multiplying 3 times the sum of a number m and 7. How can we write out the sum of a number m and 7? We'd write out m plus 7. That's a sum when we're adding. And then 3 times that. So 3 times that means we're going to multiply the entire sum by 3. We're not going to write out 3m plus 7. Because that instance, only the m is being multiplied by 3. But the way this is written, we want to multiply 3 times the sum. So we want to write in parentheses that sum so we can multiply the whole amount by 3. Next, we see the quotient of twice a number and 5 is less than 30. So quotient's a word that we don't use as much, that you might not be as familiar with. You want to pay attention to there. It means division. So twice a number. It doesn't indicate what we need to use to represent that number, what letter. In the previous example, it said a number m, so we used m. Here we can use anything we want. I'm going to use x. Okay, so that number x, twice that means 2x. So the quotient of twice a number and 5, we can indicate that division, the quotient, by a fraction. 2x over 5 means 2x divided by 5. And says is less than 30. So again, we want to take that away from the 30. Is less than 30. And we'll see a couple other things we can do here when we turn these into equations or inequalities. The key here is to look for the word is equal to, is less than or equal to. So we see the word is, that indicates an equation or inequality. Okay, in the last couple examples we saw where it said less than. That's different than is less than, which would be our inequality, not subtraction. Okay, and we see a couple of examples there. You can look over and make sure you understand how those are written out, where we see things like is for our equal sign, is at least. Okay, if you've got at least 24, it means you have 24 or more than that, so that's why you have greater than or equal to 24. Okay, so some examples there, and we'll see how we can use them as well in some further work. Here we're going to have an example, real-world type situation where we can take this and see what it means in terms of a mathematical expression. So we have a membership in a local ski club. The membership costs $70 per month and includes 8 lift passes. Okay. Then after that, we have to pay $12 for each lift pass we use more than the 8. Okay. So we want to write an expression for the total cost. So if we start out paying $70 for the month plus $12 for each lift pass. Okay, we don't want to just use X, because if we use 8 lift passes, we're not paying anything extra for those 8. Okay, so we could do a couple things here. We could say that x is the number of lift passes more than 8. We'd have to write that out and define our variable. Or we can do x minus 8. Okay, the only issue there is, what if we only use 6 lift passes? They're not going to take money away from the 70. We're going to have to pay the 70 no matter what. So we're better off writing this out with just the x, okay? But we then, again, need to define our variable, where we say x is lift passes more than 8. Okay. So if we use 10 lift passes, we're going to pay for 2 more than the 8 we get included. Okay, so for instance, in our next part, we wrote the expression. That's this part, write an expression. We wrote an expression for the total cost of skiing each month. Okay, if we don't use more than 8, then we're still paying that $70. Okay, then we see a second part to the question to find our cost for February if we went skiing 13 times in the month. Okay, so 13 times would mean that the x is equal to 5, because that's how many times we went more than the 8. So we do 70 plus 12 times 5. If we know what a variable's value is, we can plug it in for the variable, right? Turn that x into a 5. So this would be 70 plus 12 times 5 is 60, so it would be $130 for our total cost for February. So again, we're taking that situation, we're looking through, we're understanding what those words are indicating, and writing it out as something that we can use our mathematical skills on to actually do some calculations. We also want to be able to work on simplifying expressions. We don't always know what the value of the variable is, so we can't always find a value, but we can simplify. Some terms we want to be familiar with, okay? The terms in an expression in a polynomial are, in that instance we see down there in the middle of the page, right here. Okay. Our terms are negative x, 2x, and 8. They are separated by addition and subtraction. Okay? A polynomial just means something with multiple terms. Okay? Coefficient is the number part of a term with a variable. So when we write a number in front of a variable, the big name for that is coefficient. We can see that there's 2 coefficients there. In negative x, there's a negative 1. We don't have to write the 1, but negative 1 is a coefficient, and so is 2 in the 2x. Constants are numbers with no variables. So a constant that we see here would be 8. That's a constant. It's never going to change. It doesn't vary at all. It's always 8. Okay? And then we have like terms. Like terms have the same variable to the same power. So examples of like terms would be x and 2x. They have the same variable, x, to the same power, the first power. Okay? Expressions can be simplified by combining those like terms, adding and subtracting them. We're going to see some examples of how to do that here. Okay? So we want to simplify these expressions. We're not going to get a value. We're not going to find out the final answer is 12 or 18 or, like in that skiing example, $130. But we're going to do whatever calculations we can. So in this case, we have a few like terms. We have negative 2x and 6x are like terms. Those would combine to be 4x, negative 2 plus 6. And then we also have like terms negative 8 and 5. Those are constants. Constants are like terms, which would combine to be negative 3. So that could be simplified to 4x minus 3. You should pause the video, try these next couple out. When you press play and see how they're done, you'll see if you're on the right track with them. Okay, let's see how you did on these. In the example number 5 there, we need to distribute the 6 into the parentheses. Distributive property means we're multiplying that 6 into the parentheses. And then when we're multiplying this negative 2 into the parentheses, you have to remember we're multiplying a negative 2 times 8, which is negative 16, and negative 2 times 5, which is negative 10x. Okay, don't forget distributing the negative with that 2. So it's not a positive 10x, it's a negative 10x. And now we can combine some like terms. Okay, so we have 6x minus 10x. That's negative 4x. And usually we do the variable part of the expression first. And then we'd have 18 minus 16, so it'd be plus 2. So negative 4x plus 2 is what that would simplify to. In the next example, the negative 4m is going to distribute into these parentheses. Parentheses indicates multiplication. So the m minus 3, that quantity, is all being multiplied by negative 4m. So we'd have minus 4m squared. When you multiply a variable by itself, you get that variable squared. And then we'd have plus 12m. Negative 4 times negative 3 is a positive 12m. And I'm so used to writing x, that's the variable we use the most, but we didn't in this case, so change that to our m. And then we can multiply the 12 into the parentheses here. So 12 times negative 5 would be negative 60m squared, and 12 times 2 would be plus 24. Now when we look to combine like terms here, there's only two like terms that we're going to be able to combine. Okay? That's the negative 4m squared and the negative 60m squared. Same variable to the same power. We can't combine and add the negative 4m squared and the 12m because they don't have the same variable to the same power. They have the same variable m, but not the same exponent. So be careful on that. So when we combine these, we're going to get a final answer of negative 64m squared plus 12m plus 24. And that would be our final answer. That's all we can do. We can't combine anything else from that. A little pause here. Let's talk about some bacon. Of course, always a good thing to talk about. How much bacon do you think might come from a 250-pound pig? And you can see where the different cuts of meat are on that pig. That bacon section there, that's going to account for, on a 250-pound pig, they estimate a little over 20 pounds, 20 to 23 pounds maybe. So this area right in here, right, getting the bacon from there. You can see where ham, ribs, all those other things come from. If you ever heard of someone smoking pork butt, it's actually not the butt, it's the shoulder. It's actually pretty tasty. I like doing that. That's where you get your pulled pork and things from. So I'm not sure exactly why it's called the butt, but it's really the pork shoulder. When you do get that cut, go back to there. And we're going to evaluate some expressions using the order of operations now. Keep in mind, order of operations, a key thing I want to point out here. There's 6 steps listed there. Normally when we think order of operations, I know you guys use PEMDAS. Please excuse my dear Aunt Sally, however you're going to remember that. The key here is to know what those letters represent and to remember that multiplication and division are grouped together. Grouped together. You don't always multiply before you divide. Okay? You can see that this step here, right? You multiply and divide from left to right when you get to that point. First, the P is for your grouping symbols. Okay, so the P here, grouping symbols. They're not always parentheses, but a lot of times they are. Then the exponent, that's your powers. Then you multiply and divide, and then you add and subtract. Okay, so that addition and subtraction part right here, again, you add and subtract from left to right. So you might subtract before you add. You want to be very careful in some of those things, understanding the order of operations and how to use them. And here we're going to evaluate some expressions using the order of operations. When we evaluate an expression, we're going to get a value, okay, an actual numeric answer. Unlike before we just simplified, now we're going to evaluate and get a value answer. So let's try a couple of these out. We want to substitute in x equals 5 and y equals 9. So that means we're going to replace every x with a 5. The rest of the expression is not going to change. And every y with a 9. And now we need to follow order of operations. So that would start out with the part that's grouped together, grouping symbols. Our parentheses here are grouping symbols. So 5 plus 8 divided by 4, and then in parentheses 9 minus 5. And we're going to subtract there before we add. Within the grouping symbols, we follow order of operations. So 9 minus 5 is 4 plus 2, which is 6. Okay? So we have 4 plus 2. We'll write that a little better there. Okay? And that comes out to 6. So now, this expression here is 5 plus 8 divided by 4 times 6. Okay. A key here, a lot of people will multiply the 4 times 6. Because you see the parentheses, you think that must mean you're doing something with grouping symbols. In this case, this is multiplication. That 4 and then parentheses 6 is multiplication. But we need to do this division first. This division right here comes before the multiplication. So we're going to keep the 5 plus, and now 8 divided by 4 is 2 times 6. That's going to be 5 plus 12, which is 17. So a few areas there to be careful of. Again, grouping symbols first. Within the grouping symbols, follow order of operations, and then keep in mind you're going to divide before you multiply there. You don't always do M before D, so watch out for that. All right. Let's have you try these couple examples out, last couple here, and then pause the video, and when you play it again, I'll go through and we'll see how you did. Okay, now that you've had a chance to try these problems yourself, let's substitute in and evaluate. So we're going to have 17 minus negative 4. Important to have the minus and the negative 4. Plus, m is 1/2 squared. Okay, now let's get that 2 there a little neater. Alright, so now we're going to have 17 minus negative 4 is plus 4. Keep that in mind. Make sure we have the minus from here and the negative from the negative 4. We need both of those. And then plus 1/2 squared would be 1/4. When you square a fraction, you can square the numerator. 1 squared is 1, and then 2 squared is 4. So this is going to be 17 plus 4 is 21 plus 1/4. That's 21 and 1/4 would be our answer there. In this number 9, and we're going to replace every A with a 2 plus every H with a negative 7. So plus negative 7. We're going to keep in mind what that means. Then squared plus 3 times A is 2 minus 3.7. Again, every A was replaced with a 2, every H with a negative 7. Now we need to follow order of operations within this. So we're going to have 6, and then in parentheses inside the grouping symbols, 2 plus negative 7 is negative 5 squared plus 3 times 2 minus 3.7. Okay. Now we have to do our exponents. We've done everything with inside grouping symbols. Now we're going to get 6 times 25. Negative 5 squared is 25 positive. Okay, plus 3 times 2 minus 3.7. We'll bring that up here. That's going to be 6 times 25 is 150. Plus 3 times 2 is 6 minus 3.7. Okay, remember, in each of these steps, these expressions are equal to what we had before. 156 minus 3.7. Okay, and then we can finish this one off by subtracting. 156 minus 3.7 is 152.3. That would be our final answer there. And you see some different things in this. Pay attention in particular when you've got negative signs and how you're working with those, when you're adding negatives, subtracting negatives, which turns into addition, when you're squaring negatives. Okay, and each step, reevaluate what's my next thing in the order of operations. And we'll have a chance to practice all these different things. Again, working on the verbal into the algebraic, taking those words, turn them into math, and then being able to follow the order of operations when we're actually doing those calculations as well, so we can evaluate expressions with those variables in them.